So today I'm going to explain about the main memory. So I have taken this topic from operating system. So I'm just trying to record this video. I've not recorded these videos earlier. So what is background in my 15 to 20-minute lecture? So I will discuss about the swiping, contiguous memory allocation, segmentation, paging, structure of the page table. Then if time say, then we will discuss one of the example. So, what is main memory exactly? So, if if you want to run any task, if you want to perform any task in your computer system, so the task must be in main memory. We have heard about it. Okay, so as a computer science engineer or as a simple computer user, we are aware about it. So, what exactly mean it is? So it means we are storing our data into hard disk. It can be hard disk or SSD. SSD. So program must be brought into memory and placed within a process for it to be run. So program, when we are discussing about the hard disk, so if we are storing our data into disk, that can be a program, but when we are running that program, it is in process. So a program is in execution is called process. Like I want to run a video file, so that video file is stored onto our computer system, but to run that video, we have some media players. So when we are uh, running that video file, so at the time it is converted into the program process. So main memory and registers are only storage CPU can access directly. So CPU cannot directly access the hard disk. So CPU can directly access the CPU registers or main memory. Okay. So uh, CPU registers are the fastest memory in terms of accessibility. So memory unit only see a stream of addresses plus read request or addresses plus data and write request. Register access in one CPU clock. So one CPU clock means one cycle. So register are the fastest memory. So that's why the CPU is the fastest. Okay, so we are not utilizing 100% of CPU. So that this is one of the biggest tasks, how to utilize, how to increase the CPU utilization. So cache memory shifts between the main memory and CPU register. So there is another kind of memory that is cache memory. So what is cache memory? So cache memory is uh, like when we are getting the data from hard disk to main memory. So at that time we are also creating copy into the cache. So in future, if we want to run that program, so that copy is residing to the cache. So cache speed is faster than RAM, but slower than registers. So it resides between registers, CPU registers, and main memory. So uh, uh, there are two kind of registers when we are talking about the memory. So there are two kinds of registers. First it is base register, and the another one is limit registers. Okay, so base and limit. Like if my home address is 1000 square feet area, so and if I am the and there are number of blocks of 1000 square feet. So what is my base address from where my address is starting? Like the first one is 0 to 1000, then another one is 1001 to 2000, then 2001 to 3000. So if I am residing at 2001 to 3000, it means 2001 is my base address. And what is limit? The total memory, like 1000 is the limit. Okay. So in this case, you can see CPU must check every memory access generated in user mode to be sure it is between base and limit register. So here we have some memory that is reserved from operating system. Then there are number of processes you can see in this particular figure. Okay. So 256,000. So this is the process one base register. 300040 is a process two base register. In the same manner, here you can see that 300040 is the base register and 120900 is the limit. Limit means it is the total size between two registers. Okay. So limit means total capacity that is required by the block, and base means from where we are starting the address. Okay. So there is a diagram by which you can get understand okay, what is the purpose of base and limit registers, how we can identify the address generated by CPU, how we can access that address into the memory. Okay, so address generated by CPU can be different. So CPU generates an address. If that address is greater than base address, okay. So if address is greater than base address, it means it's enough or not a valid address. Okay. So here in this example, you can get if address is 30040 greater than 30040, so this is not a valid address. The address must be starting from here on. So if base address is greater than address, so we can say that no, we cannot access. So tap to operating system monitor addressing error. If address is greater than base address, then yes, we can good. Means we have some memory. Then base plus limit register. Base plus limit means how much memory we can access. So if base plus limit register is less than address, okay, so it means you can access the memory. If not less than, it is greater than, it means you are beyond your limit. It means that part is not accessible by you. Here you can get it. So like if we have base address 30040, okay, so if address is greater than this or equal to this, it means it is a valid address. Okay, if address is less than this, it means you are accessing the another process area. Got it? So here you are trying, if address is less than base address, it means you are trying to access others location. So it will generate an error. But then what we have to check, if address is valid, it means if address is greater than base address, then what we have to check it, we have to check we can only access this area only. Okay, we can access this area only. So we have to access this area only. So if base plus limit is less than, yeah, greater than, so if base plus limit is greater than, it means we are trying to access this area. So if you are trying to access this area, it means you are accessing an invalid address. It means you are not supposed to go beyond your limit. Okay, that's the point. So this is the point in these uh, uh, in this diagram. So I think it's clear. So now we have another thing. We have another criteria. So what it is? So program on disk address binding. So program on disk ready to be brought into memory to execute from an input queue. So address binding, what is binding? Binding means when we are relating something that is binding. Okay. So address binding is a kind of thing. Okay, we are getting an address from CPU and we have to actually access that address from main memory and other. So how we can bind that address that is generated by CPU to main memory or main memory? Okay, because we can directly, because CPU can access the main memory. So program on disk is ready to be brought into memory to execute from an input queue. So what is input queue? Input queue means there are a number of programs that one should run. Like in our computer system, we can double click on multiple applications. So one by one they are running. But they actually, if we have only one CPU, the CPU can access one at a time. Okay. So they are running in round robin or another fashion, time sharing. So there is a queue. So on that order, the programs are running. So without support must be loaded into address 4 times 0. So default address is this. So addresses represented in different ways at different stages of programs life. So source code address usually symbolic. Source code means when we are writing a program, so that code is source code. So like if I'm writing a program and if I'm saving that program with .c extension, so that particular file like program1.c is a source code. So compiled code address bind to relocate address. So after compilation, we have to relocate the address. So there are two terminology, linker and loader. So then linker and loader will bind relocatable address to absolute address. So there are three to four terminology like linker, loader, relocatable, absolute address. So absolute address, the address that actually we want to fetch. Relocatable address, the address generated by CPU, we have to process that address to get the absolute address. What is linker and loader? Linker, the terminology is generated with link. So if you are linking anything, so like we have a C program, like suppose that we have C program, we have printf, scanf. So printf and scanf are library functions, so they are stored somewhere. So what we have to do, we have to link these functions with our programs. Okay, so they are stored in library, so we have to use it. So we have to link those particular functions with our program. Then after linking, loader will load these functions for our program. Okay, so after loading, we will generate the absolute address where we have to go. Okay, so this is all about linker, loader, relocatable address, and absolute address. So uh, binding. So now I'm going to explain about the binding. So address binding of instructions and data to memory addresses can happen at three different stages. So we have three different stages. We have compile time. Okay. Then we have load time. Then we have execution time. So compile time means at the time when we are compiling the program, so some address is generated at that time. Load time, when loader will work, must generate relocatable code. Then execution time, binding delayed until runtime if there is a process can be moved during its execution. So like if I'm going to write a program, okay, if I'm going to write a program, then uh, program must be written, okay, with some extensions. So after writing the program, first we have to compile that program. After compilation, all the library functions will be loaded. And when all the functions will load, then it will be executed. Okay. So there are three times: compile time, load time, and execution time. So at the time of compilation time, absolute code can be generated at the time of uh, compilation time. Then load time means must generate relocatable code. So we have to convert that absolute code in relocatable. So unless I just mismatch the term absolute and relocatable. So we have to swap this terminology in as per my last word. So relocatable will generate after the absolute address. And execution, at the time of execution, when we are binding, at the time of execution, we have to need support of hardware, software. So base and limit register will also be used. So that kind particular time is execution time. Okay. Then we can explain this process by this. So we have source program, then we have compiler or assembler. So when we are processing that program into the compiler or assembler, that particular time is compile time. After compilation, an object code will be generated. So object module. So in object module, we have number of predefined or user defined classes. So we have to link those classes. After linking, so at the time of linking, this is the load time. Okay. So after load time, we have to uh, run that program. So that will be execution time. So this is uh, about the different time binding. Okay. So as limit of time, so I am stopping my PPT here, and we will discuss the same in our next uh, class. So thank you very much.